It does. So a lot of what we're going to do later on in the course, starting in the middle of chapter 4, asks us to work inside the coordinate plane. So we'll take like a triangle. I'll give you 3 ordered pairs for a triangle. You'll plot them. And then there are some segments that exist on the inside of that triangle. They're called medians, altitudes, that we're going to investigate, angle bisectors as well, but we're going to investigate them algebraically and find equations for them to see where they cross and then see what is the point in which they cross. So we'll be revisiting quite a bit of our algebra from last year, okay, talking about systems of equations and that kind of stuff and how we graph them to see points of intersection. But in order to do that, we need to have the ability to come up with equations, how to write equations from ordered pairs, okay? So that's what this is going to be about. So if you took Algebra 1 last year, it's a little bit of review. If you took integrated, this is a little bit of review, okay? First key term here is slope. Okay, obviously we use lowercase m as a symbol for slope, but it's the ratio of the vertical change to the horizontal change. Okay, so ratio is comparison of 2 numbers through division. So it's the vertical change divided by the horizontal change. And you guys know that to be called what? Slope, but you called it rise over run last year, right? Okay, so the rise is vertical change. So rise, when we say change in mathematics or science, change refers to what operation? Add, subtract, multiply, or divide. Which one of those do I do to find change in something? I subtract, right? Okay. You know, if I weighed 400 pounds and then the next year I weighed 300 pounds, how do I find the change in my weight? I would subtract 400 and 300, right? Okay. So key ideas. Slope is constant. It never changes. So if I gave you 3 points, let's see here. If I go, we'll just do this in GeoGebra real quick. All right, so I'm going to figure out the rise over run for the points. Let's just use, I don't know why I put C and D on there. We don't need C and D. Just those 2 points. Okay, so rise, and the way I got to do this in GeoGebra is a little bit different, but I'm going to subtract these y values. Does that make sense? That would give me the rise. Is it okay? So the way I'm going to do that in GeoGebra, I'm going to say the y value of point A minus the y value of point B. And it'll make sense why I could take, 0.69 minus 2.95, and it'll give me a specific number, right? But this is what this is allowing me to do then is when I move A and B, it will show me that amount changing. And I just want to check something. Yep, I knew that was going to be the problem. So I do want C and D. If I move A and B, it moves the line, but if I move C and D, see I'm moving C and D, it doesn't move the line. So those are the points I actually want to use. So let's hide those 2. So I'm going to say the change in the y of C minus y of D. So that's going to be the rise between those 2 points. Okay? And then if I do the run, it'll be x of C minus x of D. So that little equation right there in GeoGebra is just taking 1.89 minus 4.22 and then dividing that by 2.09 minus 5.74. Is that okay with everybody? And that gives me that number right there. Okay, 0.64. And that's my slope. And the idea here is if I move these points, oh, don't want to move the line, but if I move these points, okay, you see point D there moving, right, and changing in the left-hand column is 0.64 changing. Now, if I move point C, Okay? 0.64 is not changing. Even though, in this situation here, this 0.64 is now the difference in these two, or the quotient of these two differences, which is a different set of differences than these two, but because we're taking the quotient, it remains constant. Does that make sense? Okay. So what's the argument here? All I need, if I want to find the equation of a line, all I need is 2 points on that line. I don't care what 2 points they are. Okay. If I give you this line and let's say I put 60 points on it, and I tell every one of you find the slope, each one of you could potentially use different points, but you should all get the same slope. That's what we mean by it being constant. Does that make sense? Okay. Says order of subtraction does not matter. Okay, so the process here doesn't know if I'm going from slope. The way I like to think about it, and some of you said, I was terrible at slope, and usually when we're terrible at something, it's because we don't fully understand the concept, which then inhibits us from doing the operations. But what slope really is for us is a map or set of directions for you to go from a point on your line to leave your line and then come back to it. Does that make sense? Okay, that's what my slope is. My slope is a set of directions to leave the line and then get right back to it. Okay, that slope right there would be the exact same thing. Now, they're shorter distances, but if I look at that, as long as these are right angles here, they're proportional. So whatever that distance there is divided by that one is the same as that one divided by that one. They're both the same slope. So the order of subtraction does not matter, meaning that if I go back to this picture, I was going from C to D, but can I do this first? Can I go that direction and then move left to get still from C and D to connect, to leave my line and then to get back to my line? Does that make sense? So the order does not matter. All right. You guys have learned that your slope formula is rise over run. Okay. Rise over run. Okay, which is found by taking y2 minus y1 over x2 minus x1. Okay, you see there after that, I write it as y1 minus y2 over x1 minus x2 because the order that I do the subtraction doesn't matter. So this would be like going from point C to point D, and this one might be going from point D to point C. Just reversing the order. It's fine. Now, the one thing that does matter, you see that there is not a formula up here that looks this way. If I go y2 minus y1, can I write it as then x1 minus x2? I can't do that because these subscripts need to match. Okay, so the first subscripts need to be either both 1 or both 2. If I did this, the only thing that would happen is that my sign of my slope would be the opposite of what it should be. So instead of maybe increasing, your line would actually be decreasing. Which obviously is a problem. Now on your sheet, hopefully it printed right. Some of the programs I use to write my notes and then transfer them over to OneNote. OneNote doesn't have the same kind of font sets, so it didn't know what to do here. You guys should have a triangle right there. Is that correct? That print out on yours that way? Do we know what that triangle stands for? Not a triangle. Has absolutely nothing to do with a geometric shape. Have you seen that in science class before? What in the world? Well, delta y. You seen delta before? All right, so you see that in maybe some of your lab experiments or maybe your lab report that you write in science class? Is that where you're seeing it? Like a river? All right. Wonder if I can see where you can get. I can see where you're going because the delta kind of comes from a river and then spreads out, kind of triangular, right? I can see that. But anybody been to like a college campus and your fraternities and sororities? Those homes have like letters on them, like pi and delta and gamma and that kind of stuff. Kappa is one. But delta is a Greek letter. Okay, so you guys have heard of like alpha, beta, gamma, omega. Delta is one of those. No, that's like foxtrot, that kind of stuff. Now, alpha is maybe one of those, so they use part of it maybe. But delta is a Greek letter, and in science and mathematics, it stands in for the word or the phrase change in. Okay? Well, change in y and change in x, what did we already say change meant? Subtraction. Okay? So that's just a quicker way of, in a science class or math class, to say that I'm going to subtract y's, and here I'm going to subtract x's. Okay? So if I'm in science and it says, delta, and then let's just say T. Okay, capital T a lot of times in a science class talks about temperature, right? So maybe that's change in temperature. If I say delta and then lowercase t, maybe that's change in time. Does that make sense, everybody? So it's a notation, it's a symbol that refers to change, which means we're going to do subtraction. Now you might also hear it called the average rate of change. That's another word for slope. Okay, average rate of change, because we're taking a vertical change and dividing it by how many x values that vertical change has occurred between. Okay, so for instance, if I look at this image here, okay, my vertical change from point C to point D, you guys would agree that my vertical change would be that distance right there, right? Okay. Well, to go from point C to point D, horizontally, it would be that. So if I ask how much on average does the vertical height change, it's the total height divided by how many x values that it took to get from C to D. So we take that total divided by that total, and we get what we call the average rate of change. So those are all kind of synonyms that we use in mathematics to talk about slope. Okay, when you get into Algebra 2, you'll talk about this here. Okay, and this is just function notation. Okay, you guys know what functions are? Talked about that last year a little bit. A function is just a special type of graph that every x value has only one and only one y value. Okay, and the notation is that they use this little italicized f, and then they put in parentheses the x value that we're using. By definition, we know that y is the same thing as f of x. Okay, so what they're saying is that's a y value that's paired with an x sub 2, and that's a y value that's paired with an x sub 1. So it's still a y minus a y. Does that make sense? It's just a different way of labeling it. And when we talk later on in other classes, you'll realize why we have this notation. For lines, it's not going to be a big deal because all lines are functions. So a lot of times we don't see this, and I'm not going to use it a whole lot in this class. I will predominantly use the y2 minus y1 stuff. Okay. So one thing that I think is important to do in slope, at least for myself, when I'm trying to subtract these things, especially if they're aligned horizontally, so I did this on purpose because a lot of times in your homework, textbooks, Math Excel, whatever, they will give you 2 points in a sentence until you find the slope. Okay. When I do this, I will occasionally make a mistake. I'll do like 3 minus 7, and then I'll accidentally go like negative 4 minus 2. Or I'll go 3 minus 7, and I'll come back over here and do 2 minus 7. Okay, I just, for some reason, mix up my X's and Y's, and I mess up the order. So when I see something like this, what I always do is I just rewrite them so that they're underneath each other. And if they're underneath each other, then we can do subtraction like we learned subtraction in like the 3rd grade. So if I want to find the slope of AB, so the way I always write it, especially eventually we're going to be talking about a lot of different lines that we're going to find slopes of together. So I always put a little description down here in the subscript to say this is the slope of the line AB. But now I could just say, okay, well, subtract your y's. 3 minus 7, right? And then subtract my x's, 2 minus negative 4. And I just subtract straight down. Is it okay with everybody? Okay. Now, I like to write it down like that, especially if you're a person that misses these a lot. Write things down. Because what's the easiest thing to do here when I say 2 minus 4 or 2 minus negative 4? A lot of people change that to negative 2. Okay? Because they do 2 minus 4. But it's 2 minus negative 4, right? So what does that minus a negative turn into? Addition. Okay? So that is one of the key errors that people make, or the most common errors that people make. So if you know you're doing these wrong or getting the wrong answer, maybe it would behoove you to write down the actual formula so you can see subtracting negatives and that kind of stuff. And then 3 minus 7 is negative 4, right? So we like to reduce our slope, but basically what that says is now I've got a rule that says if I'm starting on my line, at some point on my line, I can move down 4 units from that point and then move right 6 units, and I will return to the line. Does that make sense? Or I can go down 2 units and move right 3 units, and I will go away from my line but then return to it. Okay? Any multiple then of that slope. So if I go down 8 and then to the right 12, will it get me back to my line? That makes sense to everybody? Okay. So that we like to talk about the slope in its simplest form, but then once we have the simplest form, any multiple of that is still a set of directions to leave the line and then get back to it. Okay. I want you guys to take a minute and figure out what the slope is for that next one. All right, so like I said, I like to rewrite my point B underneath, and then I just go 13 minus negative 8, and then negative 11 minus negative 4. And this is a situation where we've got a lot of negatives that we start off with. I think it makes sense to write it down. So you can see, it's a minus a negative, so that turns into 13 plus 8. And down here, it's still a minus a negative, so it turns into plus 4. And now we've got negative 11 plus 4 on the bottom, negative 7. 13 plus 8 on top, 21. And that reduces to negative 3, right? Is that okay with everybody? Now, when you get your slope to be a whole number, always remember that every whole number can be rewritten as a fraction, as a rational number, by putting it over 1. So I still have a rise and a run here. Okay? Now, something that also tends to give people an issue or a problem is that if I have negative 3, that is equivalent to negative 3 over a positive 1, which is equivalent to a positive 3 over a negative 1. Does that make sense? Those are equivalent statements. The number one error I get with something like this is that somebody will say negative 3 is the same thing as negative 3 over negative 1. So when I have a slope, remember our slopes are intended for us to be able to find extra points on our line, right? Well, if I do this, okay, I would be moving down 3 and left 1, where I should actually be moving down 3 and right 1, or up 3 and left 1. Does that make sense? So I want to make sure that we understand that that is not a true statement. And that will help us then when we start doing slope. Now, some people will ask me, well, a lot of times, especially with some of the questions that we get in geometry in the upcoming chapters, is they're like, yeah, you got this formula, but I can just count. I can do rise over run when you give me the picture, and I can find the slope. And I would agree with you on that. But there will be times then that I have particular situations when we're trying to do, like, trying to develop a formula or something like that, where we don't have specific values and you can't count. So, for instance, if I give you the point that A is 2A comma B, and point B is at negative C comma negative B, well, you can't count those distances because you don't know what they are, right? Where A, B, and C stand in for values, they're X's and Y's, I just don't know what they are. So here we have to use a formula, okay? So I'm going to say B, I'm going to rewrite as negative C comma negative B here. And now if I do the slope, okay, subtract my Y's. So it's B minus negative B, right? Okay. And then subtract my X's, it's going to be 2A minus negative C. So the top gives you B plus B, which would be 2B. And the bottom gives you 2A plus C. Okay. So let's kind of talk about, like, what does that mean? That's the slope. But let's talk about what that means. And I'll set this up in GeoGebra for us real quick. Yeah. Yes. So you would have negative B minus B, right? So that would give you negative 2B. And then on the bottom you're going to have would be negative C minus 2A, which now it looks, so if I go negative 2B over then negative C minus 2A, that looks different than this, right? Okay. But if I factor a negative out front, or out of the top, that becomes something like that, right? Can I take a negative out of this? If I divide everything by a negative, what's negative C divided by a negative? Be positive C, right? And then negative 2A divided by a negative 1 will give me a positive 2A. And now you see that C plus 2A is the same thing as that, right? And then that a negative divided by a negative actually turns into a positive, right? So even though it looks structurally a little bit different because of all the negative signs, if we factor negatives out, they cancel. We are left with the same thing. So what I want to do here is I'm just going to create in GeoGebra some points that are based off of these numbers, just random numbers. Okay, so and then I'm going to put 2A comma B as a point. So I'm going to say plots 2A comma B, and then it's going to plot negative C negative B. Okay, so you see that these 2 points here are being created. Basically what it's doing is 2A comma B. It's taking this A value that I set up to be 1, plugging in 1 for A, so it gives me 2, and then it's plugging in 1 for B and it's giving me 1, right? So it's plotting the point 2 comma 1, and that's where that point right there becomes. Now if I choose this A to become 2, think about what it's doing right here. A is 2, so now it becomes 4 right there, comma B, which was 1, so 4 comma 1, and you see that plots point A, right? Does that make sense to everybody? So as I move these things around, okay, I'll just move A. As I move that, or I guess I'm moving value B. As I'm changing that value B, you can obviously see that this line is changing, right? And when this line changes, what characteristic of it is changing that we've been talking about? The slope is changing, right? So the line right there, its slope is different than what it is right there, right? So if I want to know what these slopes were right now, I'd have to gather that point and do the slope. And then if I wanted to see what the slope was when I go there, I have to gather that point and that point. Okay? But what we just came up with is a formula that allows us to do it a little bit quicker. If I take 2B 2b divided by 2a plus c I get that number right there, 1.66. So now what it's doing, instead of taking these points right here and using them to find the slope, it's just taking these three numbers here and finding the slope. Does that make sense? Which is a little bit easier to do. And now the argument is, well, how do I know that that is correct? GeoGebra has a tool here. I can just click on the slope of let's click on the line, and it gives me 0.6. Is that what that formula right there was creating? 0.6, right? And I can move that C, I can move B to whatever I want, move A to whatever I want. See, my slope is negative 1.3 from GeoGebra's calculation, but from our calculation using the different formula, it's getting the same thing, right? Kind of make sense to everybody? So that's you don't do that a whole lot, and you haven't done that a whole lot, but we will as we progress through late into chapter 4. There's a couple of formulas that I want you guys to create on your own, or we'll do it together. That this procedure becomes useful for. That's called analytic geometry. When we're not using, we're in the coordinate plane, but we're not using specific values. We're using, A, B, and C, generic values. Okay, so types of slopes. You can have a line that is moving from, we regraph left to right, correct? So left to right, if it's moving upward, the slope is going to be positive. Slope is positive. Okay. What's that one going to be? Negative. So left to right. If you're moving downward, M is going to be less than 0 or negative. All right, so if you had a slope that was positive and then then you have a line that slope was negative, what number let's just say you're on a number line and you're on a positive number and you traverse over to the negative numbers. What number do you pass over to make that transition? 0, right? Okay, so we can have lines like this. Okay, that's horizontal. Okay, now think about what we're doing here. If I've got a point right there, I would have, that point would be -3, -2, and I've got a point over here, I'll just say is 4, -2. If I'm doing the slope, it would be -2 minus -2 over 4 minus -3. What's -2 minus -2? 0. What's 4 minus -3? 7. What's 0 divided by 7? If I have, let me ask you this question. If I have $0 and I say I want to split that $0 7 different ways, do you know what each person's getting? You know each person's getting $0, right? So we can do division of 0, okay, by any number we want to, unless it was 0. We can't divide 0 by 0, okay? But we can divide 0 by anything. So this means that if it's horizontal, your slope is 0, okay? Now, I'm not going to phrase that as no slope, okay? Because when we say no slope, people think it disappeared, that it doesn't exist, right? 0 is a slope. It's just there's no rise to it, okay? It's just all run. If I do this, though, let's say I've got that line right there, and let's say we got the point 3, 5 and the point 3, 1, and I do the slope there, I would have rise, which would be 5 minus 1, over run, which would be 3 minus 3. That gives me 4 over 0, correct? Can I divide by 0? No, you cannot. Okay? Cannot divide by 0. So this would be, I call it undefined slope. Okay? Some textbooks, some teachers you might have had, they would call, I'm going to put it in parentheses or quotations, they would say no slope. But that gets confusing whether that's no slope or if 0 means no slope. Does that make sense, everybody? That's why I refrain from using it. I will say it's undefined or does not exist. Okay, the slope is not a numerical value. So okay with everybody? Okay. So those are the 4 options that we could have when we do a slope. And now what I want to do is talk about writing some equations. You guys know y equals mx plus b? Seen that before? Yeah. Okay. So what is b? That's your y-intercept. That's where you cross the y-axis. Okay. M is obviously your slope. Okay. And every time that they ask us to write an equation of a line, somehow they're going to give you those 2 things. Okay. Or they'll at least give you the slope and a point. The point might not be your y-intercept, but from that you can generate your y-intercept. Okay. They might not always directly give you your slope. They might give you 2 points that are on your line. But if they give you 2 points on your line, can you find the slope? Yeah. Okay. So every one of these problems that you do throughout all of mathematics, and they ask you to find the equation of a line, they might not explicitly tell you what M and B have to be, but they might give you enough information in which you can determine them on your own through the use of some formulas. Okay, so that's slope-intercept. Have you guys seen that other formula down there at the bottom? Yeah. Okay, that's point slope, and a lot of textbooks actually show this after y equals mx plus b, but it's a little bit, I think, more intelligent to learn this one first and then learn this one. Okay, and I'll show you the reason why. What this is that this is a formula that as long as you know a slope of your line and you know a point that exists on your line, y1 and x1, that's a point that is on the line that you're dealing with. So it doesn't have to be the y-intercept. It could be any of the infinite points on your line. You plug that information into that formula right there, and you will get the equation of your line. Okay? So why do I think that this should come up first when we learn things? Okay? Obviously, the black y and the black x stay y and x. We don't change those. But here's my thought. If I'm writing an equation, and let's say that I've got that right there. That's my, what's that point called for a line? That's my y-intercept, right? Okay. Now, if a y-intercept, what's the x-coordinate of every y-intercept? Or any point that's on the y-axis, the x-coordinate is 0. Okay. Now, this is where this formula y equals mx plus b is going to come from. If I don't know what that number is, okay, that y value is being marked at, that y-intercept. So if I don't know, like, these markings, okay, I'm going to just call that an arbitrary number. And a lot of times they use b for an arbitrary number. So b could be, could be 4, could be 5, could be 2.3, could be pi. Doesn't matter, okay? But just some random y value. Does that make sense? But we know because it's on the y-axis that the x value is a defined 0. Okay? Now, I don't know any other points on this, so I'm going to say my slope, I'm just going to say is lowercase m. Okay? So let's think about this. Would you guys agree that 0, comma b is an x1, y1? Is that a point that is on my line? And my slope is m. So what I'm going to do, I'm going to come over here and say, okay, well, y minus y1. Well, what was y1? It was b. I got my m, which is going to be the slope, whatever that ends up being. And then x1, what's x1? It's 0, right? Now what this means is I'm going to distribute my m, so I get y minus b is equal to m times x. And m times 0, what's m times 0? 0. So then how would I solve this for y? Would you add b to both sides? Does that look something familiar? So what I'm trying to get at here is that though we learned two formulas, we learn y equals mx plus b, and we call that the slope-intercept form. And we learn y minus y1 equals m times x minus x1, we call that the point-slope formula. They are both the same thing. They both stem from y minus y1 equals m times x minus x1. It's just that the y equals mx plus b is that using a unique or a kind of special x1, y1. Does that make sense to everybody? But it works. Y minus y1 equals m times x minus x1 works all the time, regardless of what point you choose. So it doesn't have to be a y-intercept. I very rarely will create an equation of a line trying to use this tool here. Okay? I use this one probably 99.9% of the time, and then I'll simplify it and write it this way when I'm done. Okay? But this one here is the way I'm going to generate most of my lines. Okay? So it says these formulas are the same thing, and that's kind of the discussion that this paragraph is talking about. Just because of the time, well, let's do this. Where does our equation of a line come from? So hopefully maybe this makes a little bit of sense that these are the same thing. But you might be questioning, well, where does this come from? What's the logic behind that? Is it just somebody just made that and said that works? That's the way we're going to always write our lines. Think about this. Slope is what? What's the formula for slope? Slope y2 minus y1 over x2 minus x1. Do you guys agree with that? Okay. Now, when I'm dealing with slope here, all these subscripts is a way for me to talk about different y values and different x values, right? So if I just said like y minus y over x minus x, that's kind of confusing, right? Okay. So it doesn't matter whether I put a 2 and a 1, or it could be a 3 and a 2, it could be a 5 and a 7. It doesn't matter what the subscripts are, just as long as they're different, so I can differentiate when I'm talking about these things. So let's do this. Let's just put 1s right there. So now when I say look at y, we know that that's a different y value than when I ask you to look at y1, right? Does that make sense? So it's the exact same thing as saying y2 minus y1. It's just using different subscripts. Let's solve this for y. Let's take this equation and solve for y. So whenever you have a equation that has fractions, whenever it has fractions, you always want to get rid of fractions fast, right? So if I had like 1/2 x equals 2/3 plus 5x. Okay, would you guys, one way of approaching this, could I multiply everything by 6 right away and make everything whole numbers? So multiply by the LCD, the least common denominator, right? Okay. So I want to multiply this thing by the LCD. What's the least common denominator that we see here? Would you agree it's x minus x over 1, or x minus x sub 1, and then times my 1? Or we can think about this, is this a proportion? Fraction equal to a fraction, right? How do you solve proportions? Can I cross multiply? If I cross multiply these things, do I get m times x minus x1? That's what I get when I multiply those two, right? Do I get y minus y1 when I cross multiply those two? Is that my formula that we had up here? It's the exact same thing, right? So your equations of your lines, they're just your slope, okay? Just redefine or solve for different variables. Instead of solving for m, we're solving for y. Okay. All right. So from what you guys know from last year, if I look at this line here, y equals 2/3 x plus 1, what are you going to do first? How are you going to graph that? Okay. So first thing you're going to do is you're going to find your y-intercept. Okay. So my y-intercept is positive 1. When you're going to apply your slope, you always go from the last point you plotted. Okay, one common error that I get is people, because of what we do when we graph points, when I graph points, I always go back to 0, 0 to graph the next point, right? Okay, so if I have like a series of like 3 or 4 points, they're always referenced off to 0, 0. But when I'm applying my slope, that's always referenced off the last point you plotted. So when I go from 1, I'm going to go up 2, and then to the right 3. So when my slope is positive 2 over positive 3, positive means up and to the right. Okay, those are my two positive directions. What if I ran out of room? Like I want to go up 2 and to the right 3, but I kind of run out of room here to go 3. But I want another point. If I'm right here, where could I, or if maybe I'm even right here. We went up 2, right 3 to get to that point, right? How can I go from this point to get back to the first one? Down 2, left 3. Down 2 is negative, left is negative. What's negative divided by negative? Positive. So that's still 2/3, right? So I like to point, how many points geometrically do we need for a line? I only need 2, right? I always plot 3 because if my 3 are collinear, does it automatically tell me that the first 2 I plotted were correct? Does that make sense? Okay. If I were to plot this one here and it'd be like up there, well, I know that I've done something wrong because that's not, I connect those, that's not going to be a line. Okay. So then you take your straight edge. I'm terrible at this with my tablet, but you would take your straight edge and you would connect them and you get your line. Okay. All right. This one here, and I've got this structured this way, and it's totally up to you whether you want to leave it that way and graph it just from that, or if you would prefer to rewrite it. You guys want to rewrite it or leave it that way and graph it? Rewrite it? So if you're going to rewrite it, my suggestion, obviously you're going to put it in y equals mx plus b form, right? So I'm going to have y minus 3. I have to distribute this. So you get negative 2x minus 6. And then I'll add 3 to both sides. So I get that. Okay. So what is my y-intercept here? Negative 3. And now your slope is down 2 and then right 1, correct? Okay, or I could have gone up 2, left 1. And do a better job of connecting them than I do. Okay, here's a question. If I did this, y minus 3, write this, so y minus y1 equals m times x minus x1. I put that in that order, okay? Would it tell you, if I try to match these up, okay, would that tell you that the x value, at a point on this line, looking at that and that, would it, if I match those up, would that tell you that x1 is negative 3? Okay. If I match these up, does it tell you my y value is positive 3? Does that make sense? Okay. If let's just say I had those 2 points, can I fill in a y minus y1 equals m times x minus x1? Y minus y1, so that'd be y minus 3 equals m, which we said is negative 2 up here. X minus negative 3, well, x minus negative 3 becomes positive 3. So negative 3, 3 And that's why I asked, did you want to rewrite it or do you want to use it as it is in red? Okay, because I could plot negative 3, 3, which would be that point right there. And then I could apply my slope down to the right 1, and I can still get 2 points that are on that line. Does that make sense? I think that technique is harder. It's a little bit more confusing, I think, but it's an option if you want to use it. So that's how we plot lines, right? Our goal, I think plotting the lines and graphing them is an easier concept, okay, and just jogging your memory with that, hopefully that is something we can do. Writing the equations generally is what is more difficult inside the geometry that we're going to do in the next couple weeks, okay? So I'm going to give you some scenarios here, and we're just kind of see if we can come up with the equation of a line, okay? This first one's pretty easy, okay? And all of these, somehow they have to tell you the slope and a point, okay? So if I want to write an equation, I'm going to either use this formula here or that formula there, okay? Now, because they tell me the y-intercept, which one of those is probably the best formula to use? Y equals mx plus b. So when they tell me the slope is 3, I can put 3 in front of my x, right? And now my y-intercept is negative 5. And I've got my equation, right? That's hopefully something we've seen in the past and is a kind of elementary problem to come up with an equation. Now the next one, a little bit more difficult, okay? They tell me the slope, and they tell me a point, okay? And every time they do this, every time they ask me to come up with the equation, they have to provide that information somehow, okay? So now, is that point my y-intercept? Is this a y-intercept? No. The only way it's going to be a y-intercept is if that x value is 0, right? So the equation or the formula, I guess, that I'm probably going to use here that makes most sense would be this one. So this is my point, x1, y1. So you get y minus 5. Slope is 2. Then x minus negative 1, which turns into positive 1. And then generally the reason we're going to write the equation is so we can actually graph it. So I'm going to rewrite this as y minus 5 equals 2x plus 2. Just distribute my 2. And then we will add 5 to both sides. And I get that. You guys have maybe seen, now I know like a lot of information we're covering here, right? Just going through this fast. It is intended to be review, but if there's stuff in here that we're struggling with, didn't make sense, or we get to using this inside other geometry, you'll have this video on Schoology to go back to and revisit, reteach yourself. I've got an endless amount of examples on my website that is linked to Schoology. Have you guys ever done this? Like we can use y equals mx plus b still. I just think this is a nasty procedure to do because it's kind of confusing. They can give me a slope, so slope is 2, so I'm going to plug in m to be 2. Okay. Now, would you agree that that's an x value and that's a y value? So I'm going to come over here and put 5 for y, and I'm going to put x to be negative 1, and then add to it b. That's the thing that I don't know. Does that make sense? Okay. What's 2 times negative 1? Negative 2, right? Can I add 2 to both sides? And what does that give me? It gives me b, right? So now can I go back and say, well, started with y equals mx plus b, and I want an equation. I now know b, and I also know m was 2. Can I rewrite this as 2x plus 7 that way? Okay, that's more of a like system equations type approach, I think, to coming up with the rule here. But either one's appropriate. This one here, I multiply it through by that 2 and get that negative 2. So the third example, they don't explicitly give me the slope, right? I'm going to use 2 words throughout the rest of the year, explicit and implicit, okay? Now, I know we don't have school tomorrow, but what if I said, guys, what's tomorrow? Friday, right? What do we really like to do on Fridays? And we haven't had one in a long time. What do we really like to do on Fridays? What am I anticipating there? What am I telling you? Probably a quiz, right? Okay. Did I come out and use the word quiz? No, but I implied it, right? Okay. So that's implicit when I'm kind of hiding information to you. I'm trying to give you everything you need, but I'm hiding information, okay? If I would say, guys, quiz tomorrow, is that pretty explicit? I'm giving you everything you need, right? So this first one explicitly told you the slope and the y-intercept. This one implies it. It hides it to us, okay? If they give me 2 points, can you find the slope? Can you find the slope to be, in this case, 5 minus 4 over negative 3 minus 4? Can you find your slope to be negative 1/7? That makes sense? Would you guys agree that I could call that x1, y1? Or, I'll write this one as x2, y2, but I could call that one x1, y1 as well. Does that make sense? Okay, so they give me a point that I need, and I was able to find my slope. So now if I go y minus y1 equals m times x minus x1, that's a 3. I should be able to do that. So here I just distributed the negative 1/7 right there and got negative 1/7 x minus 7/3. And at the same time, I knew I had to add that 5 over to get y by itself, so I added 5, right? Now, what do I need to combine like terms here? So I want to add those 2 things together. What do I need with those 2? Say it again? Yeah, but this one doesn't simplify. I do want to combine them into one value, but they're both fractions, right? So if I want to add fractions, you need a common denominator, right? Is that still, it's 15/3, still 5? So now I can add those numerators. I get y equals negative 1/7 x plus, what, 8/3? Is this kind of jogging our memory from stuff that we've learned in the past? And I'm not expecting you, because I know, the quarantine last year, you should have had all this stuff before we quarantined last year. But we will revisit this stuff periodically through the rest of the year, okay? And what I mean by that is it's going to show up in multiple chapters, okay? So I would hate for you to get to the, first time this shows up in the middle of chapter 4, that be the first time that, and you struggle with it now, that be the first time that you mess around with it, because that's going to really hurt you in understanding the stuff in chapter 4. Does that make sense? So it's going to be there soon. So if you struggle with this stuff, please take the time now to ask questions, to practice, to go to my website, pull off videos, watch those, so that when we get to actually needed to use this inside a geometric concept, we can simply focus on the geometric concept instead of worrying about that along with not knowing the algebra. Does that make sense? Okay. There's a couple more on here we'll talk about on Monday. We can jump through those pretty quickly. There is an assignment in Math Excel. It's 3 point. This is section 3.7. Okay. We're going to stay with this. So all the way through next week, this is really what we're going to do. And we got Monday, Tuesday, Wednesday of next week. Wednesday, I'm going to give you a test. Okay. But Monday and Tuesday, we're going to work on this line stuff.